As a Samal, we had started doing organic, and we talked about carbon, and we talked about carbon having four electrons, four orbitals in its outer shell, and they were all empty. I mean, they needed one electron each. So carbon had four electrons in its outer shell, and there was sp3 hybridization where carbon would be bonded to four atoms. So one electron gets pulled in this direction, one over here, one over here, one over here, and you got a tetrahedral arrangement. And then you had sp2 arrangement, which was when carbon is only bonded to three atoms. So one electron gets pulled over here, one gets pulled over here, the third one gets pulled over here. No one is attracting the fourth one. So the fourth one usually ends up forming a pi bond. ठीक है अमल, is this clear?
Yeah.
And then you had sp hybridization, which is not really that common. This happens when carbon is bonded to two atoms, for example, in carbon dioxide or HCN. So since it's only bonded to two atoms, one of the electron gets pulled by one of the oxygen, the other one gets pulled by the other oxygen. So carbon's two electrons are still in their orbitals. One in the p orbital, the blue one in the p orbital, which is on a different axis. So this ends up forming two pi bonds. There's an overlap with oxygen over here, and there's an overlap with oxygen on the other side. So there's a double bond and a double bond over here as well. So you've got this is sp hybridization. So you should be able to figure out which one is sp3, which one is sp, which one is sp2. You see carbon with three atoms, that's sp2. You see carbon with four atoms, that's sp3. You see carbon with just two atoms, that's sp. Okay. So that is, and I think I told you to draw those, and you did send me the answers. Just one second, let me quickly go through the diagram. I told you to draw four molecules with
Yeah.
10 atoms. Just a second, let me just. I said this one, just a second. I said you sent me this, right?
Oh,
So,
yeah.
so you just, so I'm just going to point out the mistakes. Like, you have to remember group 4 is supposed to make 4 bonds, group 5 is supposed to make 3 bonds, group 6 is supposed to make just 2 bonds, and group 7 is going to make 1 bond. I mean, these are what the bonds are usually. So the ones that you drew, TK, which are over here, the first one looks fine. All the carbon atoms are making 4 bonds each. This one also looks fine. TK, no issues with this one. There is a mistake with this one. Can you spot the mistake? What's the mistake in this molecule?
Um, would it be that in the oxygen, because it's only making, actually no, would it be in the nitrogen actually?
TK, so
I think.
it is the nitrogen because it's in group 5. It's supposed to make 3 bonds. Yours is only making 2 bonds. So there has to be something. There has to be a third bond. So we can add an H. TK, is that clear?
Yeah.
And this one is kind of, this one looks fine. TK, this one is fine. I said, anyways, so you should be able to spot what's wrong with your structure. TK, when you make a structure, you should be able to spot what's wrong with it. Now what we're going to talk about is the different ways of representing a formula. Okay, so you have billions of different molecules. Every living organism is basically made up of these organic molecules. Okay, so the human body has billions of different molecules and cells and I mean, they're all interconnected and working interconnected with each other, and they're all reacting with each other, but most of them are organic. So So you have all sorts of, I mean, there are uncountable number of organic molecules. Now, the first thing is representation of a molecule. How do you represent a formula? The first one, number one, that's your molecular formula. A molecular formula, it basically doesn't tell you much. The only thing you're able to get from a molecular formula is the total number of atoms of different elements. So total number of atoms of different elements. Now, for example, you've got glucose, right? So glucose is C6 and H12 and O6, right? The only information that you get from that is that there are 6 carbons, there are 12 hydrogens, and there are 6 oxygens, but you have no idea what it looks like. Okay, so molecular formula not giving much information. Uh, this is what a glucose molecule. You don't know what the arrangement is. So maybe I'll be able to find a glucose molecule. I think this should be sufficient. Uh, let's talk about this one. So this is your C6H12O6, right? I'll just copy paste this 1 second. So what you don't get is you don't get this information, like how are they bonded to each other, right? So all this information is missing. Like where is the carbon, where's the oxygen, where's the hydrogen, TK, all of this stuff is missing. Now, you get this information in formulas that are known as your structural formulas. Okay, so the second one that you have is your structural formula.
Okay.
So the structural formula is any formula. It's basically any formula that provides you information about the structure of the molecule. So there are many different types of structural formulas that provides information on structure and arrangement. Right, so if you know how the particles are arranged, so even they're not, I mean, there are many different types of uh, of structural formulas even. Like for example, you have just a second. We can have a look at this one. Okay, so that's another version of the same thing.
Okay.
Okay, so it's but this one is kind of slightly different. Then there are three-dimensional formulas. Three-dimensional formulas uh, that tell you the angle as well. For example, this one over here. Okay, so here's another one. So there are many different versions of a structural formula, and so this one is kind of telling us the bond angles, like how are the bonds arranged, like in a three-dimensional space. Let me just have a look if I can spot any more. Uh, so anyways, we're going to talk about different types of structural formulas. So it's a formula that provides you information on the structure or the arrangement of the particles. So starting with the first one, and all of these are going to be types of structural formulas. So the first one, the number one, is going to be known as a fully displayed formula. Okay, that's a fully displayed formula. Now, what is a fully displayed formula? A fully displayed formula, if the question is going to ask you about a fully displayed formula, you show every single atom and every atom and every bond is shown. To get each one of them. An example is I have a molecule and there's OH and double bond O, and I have an N over here, and I have a C and a triple bond N, and there's an H over here, and there are two fluorines attached to this one. So this one is a fully displayed formula that shows every single bond in the molecule. Okay, Amal, is this clear?
Yeah.
I said then there's another version which is known as a condensed version. That's also known as a structural formula. So if you're running out of space, like drawing the for drawing every single bond and atom is kind of time consuming. So there's another version which is kind of similar. That's that's a condensed structural formula. And let's keep this over here. So that's your condensed structural. Now, in a condensed structural formula, you don't show bonds. Or you can show some of the bonds, or you can hide the bonds. You can hide some of the bonds, show the other bonds. For example, if I have a molecule like this, there is CH3 and CH2, and I've got a double bond O and a CH3, right?
Yeah.
So the condensed version is going to be that look at the first carbon, there are three hydrogens next to it. So it's C and with three hydrogens, right? So it's
Yeah.
CH3. Look at the second carbon, it's a carbon with two hydrogens, so that's your CH2, right?
Yeah.
And then you have the third carbon which has an oxygen to it next to it, so that's a C with an oxygen, right? And then you have the last carbon which is CH3. Okay, so that's your structural formula. Uh, in structural formula, what you simply do is you just start going from left to right, and you just start noting what everyone has, like what does each carbon has next to it, bonded next to it. Uh, you can work out the bonds yourself if you know what the condensed structural formula is. Uh, so, for example, and there's some rules to it. One rule is that branches are written in brackets. So branches are going to be written in brackets. So that's one rule. What that means is, like, if you have a molecule, branches are things that are coming out of it, like going to the top or bottom. So I've got N with two hydrogens, and there is a CH3, and then there's C double bond O, then another O, then there's C, and I've got OH, and there's H, and followed by C with three H's, and there's another C with three H's, and I've got an OH over here. So this is kind of is this a fully displayed formula or not?
Yeah.
ठीक है. But it's like 95% fully displayed. Like in a fully displayed, you even show the OH bond. Like I didn't show the OH bond to make it.
Oh, okay.
ठीक है. So to make it a fully displayed formula, I'm going to show the OH bond as well, so we can explicitly show every single bond. ठीक है? Every single bond has to be shown for a fully displayed formula. Anyways, I'm going to condense it now. And remember, branches would be written in brackets. So where do you see the branches? There's this thing coming out on the side. I mean, there's one H missing over here. So let me add that. What else is coming? There's an OH that's coming out of the main chain. There's a CH3 that's coming to the side. There's another OH over here. So you start moving from left to right. So when you start moving from left to right, it's the first one is, let's start with the first one. So that's your carbon with three H's. So that's CH3. Let's then move to the next one. That's a carbon with an H, but then it has an NH2, but that's a branch. So you're going to write NH2 in brackets. Okay, is this clear?
Yeah.
And let me change the color of this thing. So NH2 would be written in brackets. After NH2, you've got a CO. So you got a CO, and after that CO, we got another O. So there's another O, and after that O, there is CH, and that CH has an OH branch. So I'm going to put the OH branch in brackets. There's an OH branch coming to the side. Then we move to the next carbon, which is the next one has two branches coming out of it. It has an OH branch to the top and a CH3 branch at the bottom. So you got OH, put that in brackets, and at the bottom you got another branch which is CH3. So put that in brackets as well, and finally, right at the end, you got another C with three H's. Okay, so Amal, is this clear?
Yeah.
So that's how you write condensed structural formulas. Okay, so I'm just going to give you. Let me find a worksheet. Okay, maybe there's a worksheet on this. Just a second. Or I can just give you questions myself. Just a second. So okay, let's. These are the questions. You're supposed to write condensed formulas for these. Okay, so I'm posting them here. ठीक है, so I've posted the questions over here. Try and just send the answers on WhatsApp as quickly as possible. अच्छा ठीक है. So first one ठीक है, that one is fine. The second one is fine. Some things, I mean, this doesn't look. I mean, the third one doesn't look right. It's starting with, let's. I mean, you go from any side. Let's say you go from left to right. So the first one is, I mean, this carbon atom over here. ठीक, the one I've pointed.
Yeah.
That's CH3, right? You move to the next carbon atom. So that is, I mean, there's this branch coming out of that one, right? So that carbon atom
Yeah.
is CH, followed by a branch that's coming out of it. That's your CH3 branch. And then you move to the next carbon atom, so that's CH2, and then you've got OH. ठीक is so the end is fine, but even this part is kind of fine. I mean, there could have been uh but it kind of makes sense. I mean, it's I mean, you can say that it's correct because I think what you did was you looked at this CH and you figured out that it had two branches, one CH3 over here, one CH3 over here.
Yeah.
ठीक, so in a way that can be correct as well. So let's look at this one. It's again, you're looking at this one. I just told you go from left to right. ठीक, so again, I think you're looking at this one. So it has an OH and it has two CH3s. Sorry, it has three CH. I mean, why is there CH4? Is there a CH4 anywhere? I think you cut it
No,
out.
yeah, crossed it out. Crossed it out.
Okay. I said, so from that perspective, that's fine. But if you like go from left to right, so the first thing you're going to meet is this carbon atom. So it's CH3, right?
Yeah.
Then you meet the second carbon atom. This one has a branch coming out of it. So that's the second carbon atom is C, and it has two branches coming out, one going up, one going down. So there's an OH, and there's a CH3 at the top as well, right?
Yeah.
And then you have the last carbon atom, which is CH3. But yours is also it can make sense, kind of makes sense. I said now remember one thing that you could have done was that since you were just looking at the middle carbon atom and you wrote that there were three CH3s next to it, what you could have done was it's I mean you could have written it as C and there's OH, right?
Yeah.
With I mean if it's the same branch that's repeating over and over again, you just write three. Is that clear?
Yeah.
ठीक, so you could have written it that way, and uh, this one looks fine. I said you don't put a bracket if there's just one of them. Like, I mean, the bracket over here is kind of pointless because even if you don't put it, I mean, it won't really matter. I mean, you put brackets around branches. I mean, this is not a branch. It's just straight, completely straight. So no need to put a bracket around it. And the last one is again, I told you to start from. So it's going to be CH3, then it's going to be moved to the next carbon atom. So that's CH, and with a CH3 branch at the bottom. And then you have an O, and you have another CH3. ठीक है? So,
Okay.
so that's how you write condensed formulas. Now, there's another type of formula which is uh, so two types. One is fully displayed. You show every single bond. That's your fully displayed formula. Then this is your condensed formula. I mean, there are lots of in betweens. Like you can condense some of the portion and show the rest. ठीक, for example, you can write this as CH3. You can write this as OH. You can write this as OH. You can write this as NH2. ठीक, do you get the point?
Yeah.
I mean, this one and this one, there would be a lot of in betweens. ठीक, partially condensed, partially showing all the bonds. So what we are going to do now, the third way to represent a molecule is a skeletal formula.
Oh, okay.
Now, what's a skeletal formula? That's kind of like a shorthand for writing organic compounds, because the condensed ones, writing the condensed formula gets kind of confusing. I mean, it's pretty hard to actually figure out who's making how many bonds. Like, it's very hard to get this condensed formula correct, because you don't know. I mean, you can look at the structure, you can figure out if there's something wrong with the structure, right? But you can't really figure out whether there's something wrong with this or not. Do you get my point?
Yeah.
So, a shorthand for writing formulas, that's your skeletal formula. And just let me open it. So what happens in your skeletal formulas? What happens is you you don't show most of the things in a skeletal formula. Like, you don't show carbon atoms. You don't show hydrogen atoms. You also don't show carbon and hydrogen bonds. So they're simply not shown, not drawn. So that's going to save you time. I mean, most of the organic molecules are just a bunch of carbon and hydrogen atoms joined together. So if you're not showing them, so you're not drawing most of the molecules. So what are you showing actually? What you're showing is just the carbon-carbon bonds, and functional groups are shown. Like, functional groups are the groups that are attached to it, like these OH groups or NH2 groups. They're shown. So functional groups, they are shown. So, for example, I want to write the skeletal formula of this molecule, and this one is a fully displayed formula showing every single bond. So, how do I write this skeletal formula? Remember, don't show anything. No carbon bond, no carbon atoms, no hydrogen atoms, no carbon. So, what is going to be shown? Just these carbon-carbon bonds. So I'm just going to highlight them. I mean, you're basically showing this. You're showing this. You're showing this bond, right? So only these bonds,
Yeah.
nothing else is shown. And the functional group is shown, which is this thing. Okay, that's it. So how do you show just three bonds? So the three bonds are shown as 1, 2, and 3. That's it. Let me. So it's 1, 2, and 3. And the nodes of this, although they're not shown, but the ends or edges or the points, the nodes of this structure, these are carbon atoms. Is that clear? You had four
Oh,
carb
okay.
you had four carbon atoms, but you're not allowed to show the carbon atoms. You're not allowed to show the hydrogen atoms. So you're just allowed to show the carbon bond. So that's 1, 2, and 3. So that's one bond, two bond, three bond. You're not going to draw straight lines, because then it would be very hard to actually figure out where the carbon atoms are. So the ends of these bonds are carbon atoms. And the other thing that you're going to show is the functional group. So on the fourth carbon atom, there's a double bond O, right? On the fourth carbon atom. So you got to show that. So you got a double bond O at the end. Okay. Is this clear?
Yeah.
So let's try and make skeletal formulas of these things. Like starting with the first one, uh, what are you going to show? Just the carbon-carbon bonds. So it's one, two, three. So three dashes, okay? So I'm just going to draw three dashes. That's one, two, and three. Uh, the nodes or the ends of these lines are your carbon atoms.
Okay.
And you have to show the functional group. So there's an OH on the last carbon atom. So you got to draw that. So there's an OH on the last carbon atom. ठीक है, clear Amal?
Okay.
So try just try and draw the skeletal formula of all of them. ठीक है, just try it. ठीक है, even if they're wrong, doesn't really matter now. So I'm just sending it on WhatsApp.
Okay.
So try and draw the skeletal formula of this, of each one of them. ठीक है? चलो ठीक है. Clear it. Send it on WhatsApp. ठीक है, the solution. So do you have any
Okay.
questions?
No, that's fine.
चलो ठीक है. Let's continue next time then. ठीक है? Okay, Amal, take
Okay.
care. Allah Hafiz.
Okay, bye. Have this.